Okay, students, in this clip we're going to be going over some review problems on quadratics, the factoring process, and also conic sections. Okay, so let's go ahead and take a look at question number 1. We have, it says the total area of a rectangle is given by 49x to the fourth minus 16y squared. Which factors could represent the length times the width? So we have a rectangle. Let me make a sketch of the figure. So let's say we have a rectangle, and the area is the interior region, is represented by 49x to the fourth minus 16y squared. So if we want to find the length and the width, all we just simply have to do is factor this expression, okay? So how do we factor 49x to the fourth minus 16y squared? If we examine this expression closely, we'll notice that this is a difference of squares. So to factor a difference of squares, what you do is you root the first and the last, and then you add and subtract the square roots, okay? The formula for difference of squares factorization is a squared minus b squared equals a plus b times a minus b. Okay, let me write that again. So it's so a squared plus b squared, or minus b squared, is equal to a plus b times a minus b. You basically square root the first and the last, add and subtract. If you square root the first term here, what you're going to have is 7x squared. Remember, anytime you square, you divide the power by 2. So this becomes 7x squared plus the square root of 16 is 4. Square root of y squared is y. So plus 4y times the same thing with the difference, 7x squared minus 4y. So this represents the dimensions of the area. So let's see which one matches with what we have. 7x squared, this option A matches. You know that multiplication commutes, so this, or we can also write it as 7x squared minus 4y times 7x squared plus 4y. So the answer to number 1 is clearly option letter A. Okay, let's shift to number 2. Number 2, we have a quadratic equation we are asked to solve. We have x squared minus 10x plus 29 equals 0. If you look at the options, you notice that we have imaginary solutions, so factorization is not going to work here. So let's just assume that we weren't that observant, and we just try to factor blindly. So make our x, AC is 29, and then b is negative 10. What two numbers go into 29? Only 1 and 29, since 29 is prime. And no combination of 1 and 29 can yield 10. It can only get 30 or 28. So this is a prime expression. So we have to solve it using another method. We can either use the completing the square method or the quadratic formula. Let's go ahead and use completing the square. So first thing I'll do is I'll create an incomplete square by subtracting 29 from both sides. So we have an incomplete square on the left, so this becomes x squared minus 10x equals negative 29. And to complete the square, remember what you do is you add b over 2 square. That completes the square. Okay? Alright, so let's go ahead and do that here. In this case, b is negative 10. When you divide it by 2, you get negative 5. And then when you square negative 5, you get 25. Alright, so that completes the square. So to get it prepped for that, we're going to write it as x squared minus 10x plus the term that completes the square equals negative 29 plus the term that completes the square. Okay, so the term that completes the square here is 25. So you insert a 25 here and a 25 here. We have a perfect square trinomial on the left side. So we're going to factor that. So what you do is you take the square root of the first and the last and bring down the middle sign. Okay, so we're going to have x minus 5 quantity square, and then negative 29 plus 5 is negative 4. Alright, so to solve this, we'll take the square root of both sides. Square root, square root. And then we're going to have the absolute value of x minus 5 equals square root of 4, negative 4 is 2i. Remember, anytime you square negative, uh, you always have an I. Okay, the negative comes out of the radical sign as an I. So this can be written as plus or minus x minus 5 equals 2i. We can divide both sides by plus or minus 1 to move that sign to the other side. All right, so let me break it down. Let's split the page down the center. So if we shift over here, we're going to have, so go over here. We're going to have x minus 5 equals plus or minus 2i. And then we just add 5 to both sides, add 5, add 5. So we have x equals 5 plus or minus 2i. Okay, if we split up the answers, our solutions are going to be 5 minus 2i and 5 plus 2i. Okay, 5 minus 2i and 5 plus 2i. And then we can see that our answer is option letter D. Okay, option D is our answer. Okay, let's move on to the next example. Number 3 says the quadratic function fx equals x squared plus 2x minus 3 is graphed below. What are the zeros of the function? So basically asking where does the graph intersect the x-axis. So you see it intersects at 1, 2, 3. So the first zero for number 3 is negative 3. That's the first zero, and then the next one is positive 1. All right, so don't forget the zeros are the same thing as the x-intercepts. So zeros are the same thing as x-intercepts. Okay, and we can clearly see that the answer here is letter C. All right, for number 4, we have we asked the factor sum of cubes. So for number 4, we have 8x to the third plus 125y to the third. So since this is a sum of cubes, we're going to use the sum of cubes formula. The sum of cubes formula is, so let's write the sum of cubes formula. A cubed plus b cubed is equal to a plus b. You keep the sign first, and then a squared. You do the opposite of the sign in the center, minus ab, and then the last sign is always plus. All right. So to factor this, all we need to find is a and b. So to get a, what we'll do is we'll take the cube root of the first number, 8x to the third. And when we cube root that, we get 2x. And to get b, you take the cube root of the second number, 125y to the third. And if you cube root that, you get 5y. Okay? All right. So some of you might ask, how do you do cube root in a calculator? Well, it's not that complicated. To calculate a cube root, all you do is you raise the number to the 1/3 power. So if I want to do cube root of 8, for example, I'm going to put parenthesis 8 raised to the caret, parenthesis 1 divided by 3. All right? And that will give me what the cube root is, which is 2, sorry. Since this is a TI-89, I can evaluate the algebraic expression. So 8x to the third. If I wanted to do the cube root of that, I'll just simply raise it to the 1/3 power. And that's going to give me 2x. Okay, and then 125, if I wanted to do 125 y to the third, if I want to find a cube root, all I'll simply do is raise it to the 1/3 power. And the answer is 5y, as we can see here. Okay, all right, now that we have a and b, we're just going to plug it into the formula. So the factored form is going to be 2x plus 5y times, now you have to be really careful here. When you're squaring 2x, you have to have 2x squared. You square both of them. Okay? 2x squared minus 5xy is simply going to be 10xy. And plus b squared, so 5y squared. All right? If you look at the options, we can eliminate options A and C since they have a minus here. So it cannot be A or C. And then if we look at B and D, This has plus plus, whereas the answer is supposed to be minus plus. So we can see that option D is the answer. But let's finish it up first. So we have 2x plus 5y times 2x squared is 4x squared. You have to square the 2 and the x minus 10xy plus 25y squared. All right, so the answer is option D. All right, let's take a look at question number 5. We have an ellipse that has been sketched for us, the graph, and we're asked to find the equation. All right, so first thing we want to determine is the center. The coordinates of the center is -3, +1. If you count 1, 2, 3, -3, +1. And the A, so you're going up and down, 1 unit. Okay, so to get the direction for up and down, you're going 1 unit up and down. So the B value is going to be the square root of that length, of the square of that length. A is going to be side to side, and we're going 3 units side to side. The reason why I'm calling A the side to side direction because that's the major one. So to get A is basically going to be 3, and then B is going to be 1. All right, because we're going side to side 3 units, and then we're going up and down 1 unit. A always goes with the major axis, okay? So if we want to formulate the equation, we're going to write x. You do the opposite of the x coordinate, plus 3, quantity square, and then you square the direction that you're going in the x direction. So you're going 3 units left to right, so you have a 9. Okay? Let's see, do we already have an answer? Yeah, we already know what the answer is. We can see that the answer is C just by doing the first part. Okay, but let's finish it up though. So plus on the second part, we have y. You do the opposite of the y coordinate, -1 squared, divided by the number of units you go up or down. You square that. 1 squared is just 1, and then equals 1. So the answer is option C. All right, let's take a look at question 6. It says Tina correctly solves the equation x squared minus 6x equals 11 by completing the square, which expression represents a step after the square has been completed. So this is an incomplete square. To complete the square like we talked about before, we add b over 2 squared to both sides. In this problem, b is -6. So what do? We divide that by 2, -3, and square it, you get 9. Okay, so to complete the square, we're going to have x squared minus 6x, and then we're going to add the term that completes the square equals 11 plus the term that completes the square. So the term that completes the square is 9, so we add 9 to both sides. All right, and then now we have a perfect square trinomial here. Let's factor it. Okay, so if we root the first and the last and bring down the middle sign, that will be the factorized form of this expression, which is x minus 3 quantity square. And on the right side, 11 plus 9 is 20, equals 20. So the correct answer to number 6 is option D. Okay? All right, let's take a look at the next problem. For problem 7, we are asked to write the general form of the equation of a conic in standard form. So we have x squared plus 3y squared minus 4x minus 5. This is clearly an ellipse because you notice that we have 2 squares and a plus, and the coefficients are different. Okay? So to do that, to write this in standard form, first thing we'll do is organize our variables. So we have x squared minus 4x, the x's together, and then plus 3y. 3y squared doesn't have any y with it, so it stands alone. Add 5 to both sides. Since it's a constant, it goes on the other side. Now we're going to partition our worlds. We have the x world and the y world. Now, if we look at the x world, are we ready to complete the square here? Absolutely. So let's express it as an incomplete square. How about in the y world? Well, y is already a square, well, a multiple of a square. So what we'll do is we extract this 3 and write this as y minus 0 square. It's already a square. Okay? All right. Now let's complete the x world since y is already complete. So to complete the x world, all we just need is the b of the x world. Okay, b of the x world is -4. We divide that by 2. which is negative 2, and square it, which gives us 4. So that completes the square in the x world. So let's write this down. We're going to have x squared minus 4x plus the term that completes the square in the x world. And then why we don't do anything with that, just leave it alone. And then since we're adding a term to the x world on the left side of the equation, we have to add the same term on the right side of the equation to preserve equality. Okay? So we're introducing the 4 to the x world on the left side, so we have to introduce the 4 here also. So now let's go ahead and factor this perfect square trinomial we have. You read the first and the last and bring down the middle sign. So the factored form of the x world is going to be x minus 2 quantity squared plus 3 times y minus 0 squared equals 9. Okay? We know the standard form of the equation of an ellipse is always equal to 1. So to accomplish that, we have to divide every single term by the constant on the right if it's not 1. It's not 1, so it's 9. So we have to divide everything by 9. Okay? So that yields x minus 2 squared over 9 plus 3 goes here 1, 3 goes here 3 times. So plus y minus 0 squared over 3 equals 1. All right? So we can clearly see that our answer is option letter B. Okay, so we have x minus 2 squared over 9 plus y squared over 3. You can ignore this 0. In the options, it wasn't placed there, so you can also drop it and write it like that. So option B is the answer here. All right, let's take a look at question 8. We have an area model. A of x equals 18x minus x squared. And we're asked to find the maximum area. Okay, if you look at this quadratic, this represents a quadratic function that is facing downwards. Because if you look at A is negative 1. A in this problem is negative 1, and B is 18. So since A is negative, it faces downwards, so the extrema is going to be a maximum. So the question is, what is that value? So we know from the formula for a vertex that the maximum is the same thing as the y-coordinate of the vertex, and that's determined by looking for f of negative b over 2a. Okay? And this negative b over 2a is also known as the x-coordinate of your vertex. So let's find negative b over 2a first and then plug it into this function to determine our maximum. Okay? So the x-coordinate of the vertex, which is negative b over 2a, let's compute that. It's going to be negative 18 over 2 times negative 1. So you're going to have negative 18 over 2 over negative 2, sorry, and then 9 will be your the x-coordinate of your vertex. Now to find a max, we're going to evaluate f of 9, which is technically a of 9, which is going to be 18 times 9 minus 9 squared. All right, so we have, so it's going to be 162 minus 81, which equals 81. Okay, so the maximum area is 81 square feet. Okay, so our answer is clearly option C. All right, let's take a look at question 9. We're asked to, this is the function for the graph f of x equals x squared after translation 5 units to the left, and 8 units down is given by what? So let's go ahead and write down the function. We're going to have g of x. Now, we have a number next to the x, square. So if we go 5 units to the left, we're going to do the opposite. So left, the opposite is going to be plus, so plus 5. And then if you go 8 units down, that's going to be minus 8. Okay? So if you shift 5 units to the left and 8 units down, the vertex is going to be 5, negative 5, comma, -8. And if you want to write it in vertex form, what you do is you do the opposite of the x and place it next to the x. And since the other number is not next to the y, you just take it as it is and place it right there. And that gives you the equation of the function, the translated function in vertex form. So you can see that our answer is clearly option letter A. All right, let's take a look at question 10. It says, during the years 1992 through 1996, the average number of grapes is given by the model g of x equals -25t to the third plus 3t plus 20. And the average number of red grapes, this is green grapes, and then red grapes were given by r of t equals 24t to the third plus 11t squared plus 30. What is the total number of grapes? Okay, so the total is going to be the sum of red and green grapes, of course. So n of t is simply going to be g of t plus r of t. Okay, so n of t is going to be g of t is given by -25t to the third plus 3t plus 20. And then r of t is going to be 24t to the third plus 11t squared plus 30. Okay? All right, so I need to rewrite this so that it's easier to add. Let me just make a real quick change here. This is missing the square term, and this is missing the t term. So let's write that properly. So since it doesn't line up, I have to be careful. So this one doesn't have a t square. It just has plus the g of t plus 3t plus 20. Okay? And then this one is 24t to the third, and then t squared plus 30. Okay, you can put a placeholder if you want. For example, since this doesn't have a square, I can put 0t squared. And since this doesn't have a first degree term, I can put plus 0t. Okay, so we want to be careful not to add terms of different degrees because they are like terms and cannot be combined. Okay, so organize it like this. Check your columns to make sure that the degrees are identical before you can combine them. Okay, so these are identical. You can combine them into -t to the third. Add this up, becomes 11t squared. Add this up, this becomes plus 3t. And then when you add that up, you have plus 50. Okay? So you can clearly see that our answer for number 10 is option letter B. All right, let's take a look at question number 11. We're given two quadratics in vertex form, and there's a translation happening. So we are starting from, from the start, we're starting from y equals x plus 8 quantity square minus 9, and then we're stopping at from here to y equals x minus 3 square plus 5. And the question is, which one describes the translation? So all we just have to do, we can just do the vertex of the stop minus the vertex of the start. Okay, that tells us how much the move was or is, okay? So the vertex of your stop is basically the terminal vertex, which is +3. You do the opposite of that on 5, minus the vertex of where you started from, which is -8, -9. So you can write this as 3, 5, and then you distribute the minus to these two numbers here, so you have 8, 9. All right? And then when you add downwards, you end up with 11, 14 as the coordinates of your vertex. So since they're both positive, what does that mean? It means you're going to go 11 units to the 11 units to the right and 14 units up. Okay? 11 to the right because along the x-axis, and then 14 units up because that's along the y-axis in the y-coordinate. So you can see that our answer is option letter A. All right, let's take a look at question 12. It says there are two numbers with the following properties. Property number 1, the second number is 1 more than the first number. And we look at the choices we have. The second number in each group, in each alternative is one more than the first. So A, C, and D satisfies that requirement. And then option 2 says the product of the two numbers is one more than their sum. So let's say we have two numbers, A and B. Um, so let A be the first number and B be the second number. So it says here that the product of the two numbers, so A times B, is going to be is one more than your sum. So if you take the product of the two numbers, we can write it as equal one more than your sum. So your sum is A plus B. So this is one more than your sum. So your sum plus one. Okay, so remember is like the equal component in the algebraic form of this verbal description here of property 2. All right, so let's test these alternatives to see which one meets this requirement, since they all meet requirement number 1. So let's test option A. The question is 1 times 2, this is option letter A, is 1 times 2 equal to 1 plus 2 plus 1? That's the question. So we know that 1 times 2 is 2. 1 plus 2 is 3, plus 1 is 4. So is 2 equal to 4? The answer is no. So option A cannot be the answer because it doesn't meet property 2. Let's shift to option C. And note, if option C and D do not work, then B will be our answer because there are no solutions. All right, so let's try 2 and 3. The question is 2 times 3 is a product equal to the sum of the two numbers 2 plus 3 plus 1? 2 times 3 is 6. 2 plus 3 is 5 plus 1 is 6. 6 equals 6. That checks. So our answer is option letter C. All right, let's take a look at question number 13. It says, which expression shows the complete factorization? The complete factorization of 45x squared minus 39x minus 60. So which of these options show the complete factorization of this expression? All right, the first thing we're going to do is decompose each term completely to see if we can extract the GCF. If we decompose 45, let's do that on the side here. 45 is, it ends in 5, so 5 goes into it for certainty. 9 times, take out 3, 3 goes into 9, 3. All right, so that's 45. And let's decompose 39. Since the sum of the digits is divided by 3, then 3 goes into it for certainty because 3 plus 9 is 12, and 3 goes into 12 4 times. 3 times 13. So that goes the decomposition of 39. For 60, that's even, so 2 goes into there. 2 goes into the 60 30 times. 2 goes into 30 15 times. And 5 goes into 15 3 times. So there goes the decomposition of 60. Okay? All right, so let's put it in the expression. So 45 is 5 times 3 times 3 times x minus 39 is 3 times 13. 3 times 13, let's write that again. 3 times 13 times x. 3 times 13 times x. And then 60 is 2 times 2 times 5 times 3. All right, so what is common in all three terms? If you notice, there's a GCF. The GCF is 3. So we can extract 3, 3, and 3 out of the expression. So that gives us 3 on the outside. All right, so and then in the parentheses, we have 3 times 3 is 9 times x times x. 9x squared minus 13x minus 2 times 2 is 4 times 5, 20. Okay, now let's factor the interior expression using the x game. So make your little x. AC goes on the top, B goes on the bottom. So AC is 9 times 20, which is negative 180. And B is negative 13. All right, so let's see what works here. It looks like I made a mistake. Let's fix that real quick. 5 times 3 is 15. So my AC is going to be 300, negative 300. Okay, so if you look at this, if you take out 3, you're left with 5 times 3, which is 15x squared. When you do AC, you have negative 300. Okay, so two numbers that multiply to give you 300 and add to give you 13. We can use 10 and let's see. Well, let's write down the factors, all the numbers that multiply to give you um, 300, and then see which one adds up to 13. Okay, so we have 300. Let's break down 300 into its factors, pair of factors that multiply to give you 300. So we have 1 times 300, that doesn't work. 2 times 150, that doesn't work. And then we have 3 times 100. See, that doesn't work either. All right, so we can try 4. 4 goes into 375 times. That doesn't work. Let's try 5. Goes into 360 times. That doesn't work either. So we're going to keep writing down all the factors. Let's see. 6 goes into 300. See, 6 goes into 35, 550 times. That doesn't work. This gives us 60 and it gives us 56 and 44. So 7 doesn't go, 8 doesn't go, 9 doesn't go, 10 goes into 330 times. That doesn't work. And then 12 goes into 325 times. Well, that works. So let's put that in. 12 and 25. So we're going to have 3 times 15x squared. 15x squared. Now let's put that here. We have 12 and 25. Since the sum is different, is negative, the sum is negative, so the bigger number has to be minus. So minus 12x minus 25x minus 20. Okay? So break it down to center or factor by grouping. So we're going to have 3 times, the first one is 3 times 5 times x, and then 12 can be broken down into 2 times 2 times 3 times x, minus 25 can be broken into 5 times x, and then 20 can be broken down into 2 times 2 times 5. Okay? Alright, let's extract common factors. On the first, on the left side of our partition, we can take out 3x from these two. So that yields 3 times 3x on the outside times 5x minus 4. And then on the right side of the partition, we can take out a 5. Alright, so I'll take out a 5. We have minus 5 times 5x, so minus 25. Oh, this is supposed to be a plus, plus, plus. Alright, or else it will match. Alright, so times minus 5, 5x plus 4. Anytime you factor out a negative, this has to change. So this is where we stop and check to make sure we're correct so far. And the question is the quantities in this parenthesis the same? The answer is yes, they're the same. So our factorization is accurate so far. So to finish it up, we'll have 3 times these two identical factors, 5x minus 4 and 5x minus 4. Put them together, times 5x plus 4. And then the other term on the outside, 3x minus 5, we'll put them in their own parentheses, times 3x minus 5. Okay? I can clearly see that the answer here is option letter D. Okay, let's move on to number 14. Number 14, we're composing two functions. So to do that, you're going to plug in one function into the other. So you have to find f of g of x. So in this case, you're plugging in g into f. All right, so if f of x is x squared plus 5, and g of x, which is what we're plugging in, is negative 2x squared. So f of g of x is simply going to be, instead of x squared, you have negative 2x squared plus 5. All right, now that reduces into, you square the minus, it becomes plus. When you square 2, you get 4. And then when you square x squared, you get x squared plus x 2x squared square. There's a square here, so you multiply that 2, so this power ought to be a 4. So 2x squared square is basically 4x to the fourth power plus 5. All right, and then our answer is option letter D. So f of g of x simply means you plug in, substitute g into the x's in f. All right, so this was the x for f, so we just took negative 2x squared, and then we substituted it in to the x. That's how we got this expression right here. All right, let's take a look at question 15. And we asked to write quadratic in standard form in vertex form. So for number 15, we have y is equal to x squared plus 4x minus 6. So to do that, we have to complete the square here. So um, let's first of all identify our incomplete square. So this piece right here is an incomplete square. So we have y equals parentheses x squared plus 4x and then minus 6. Are we ready to complete the square? Absolutely, since x squared has a coefficient of 1. So to complete the square, we're going to do b over 2 squared. So in this problem, b is 4. We'll divide it by 2. 4 over 2 is 2. When you square 2, you get 4. So that completes the square. Okay? So what we're going to do, let's set it up. We'll have y equals x squared plus 4x plus the number that completes the square, minus 6. Since we're adding a number to the right side, we have to subtract that same number from the right side so that it cancels each other out. Okay? So we added a 4 plus 4. So we're going to minus a 4 from here also. Okay? And then when we do that, we can now factor the perfect square trinomial we created. We root the first and the last. Bring down the middle sign. So this is now going to become y equals x plus 2 quantity square minus 6 minus 4 is minus 10. And as we can see, our answer is option letter A. Okay? All right, let's take a look at question 16. So for 16, we have a hyperbola, the graph of a hyperbola, and we asked about which of these equations is for the hyperbola. Now we can use a process of elimination to narrow down our options. Since it opens in the x direction, left and right, that means that y has to be negative. Okay, so option B and C have to be eliminated because y is positive and x is negative. So these two cannot be the answer. It's either A or D. Okay, so out of A or D, let's focus on the coordinates of the center. The coordinates of the center is 1, 2, 3, negative 3, comma, and then you're going to go up 1, 2. But from look of things, it looks like we're going up by multiples of 2 since these two have 4. So let's say it's negative 3 and 4. Assuming we're going by 2's, okay? So if we wanted to write this in standard form, we're going to have x. We have to do the opposite of that. X plus 3 quantity square, right? Over, since you're going side to side 3 units, you square that over 9 minus, and then for the y, you do the opposite, minus 4 square over, since you're going up and down 2, the denominator is going to be, well, there's an error in this problem, so yeah, this is supposed to be, since you're going up and down 2, this is supposed to be 4 equals 1. All right, so we can clearly see that our answer for number 16 is option A because that's the one that matches our vertices. So option A is the answer for number 16. Okay, we're going to jump to number 18. In number 18, we're asked to state which quadratic equation has roots negative 1 and 8. So if two quadratics have the same roots, then in standard form they must be identical. Okay, so we have 6 options. So how about we place all of them in standard form and see which ones are the same. Okay, so we have x squared minus 8 equals negative 7x for option A. To place this in standard form, we'll add 7x to both sides. So the equation is going to be x squared plus 7x minus 8 equals 0. Take a look at option B. We have x squared minus 3x equals 10x minus 8. To place it in standard form or make it equal to 0, we subtract 10x from both sides and add 8 to both sides too. Okay, so this cancels out. And we're going to have x squared minus 13x minus 13x plus 8 equals 0. Okay? All right. Let's take a look at option C. Option C is already in standard form, which is x squared minus 7x minus 8 equals 0. Let's take a look at option D. Option D is 1 minus 8 over x squared equals 7 over x. To place this in standard form, we're just simply going to multiply the entire equation by the LCD of x squared and x, which is x squared. Okay, so we'll multiply through. We're going to have x squared minus 8x squared over x squared. Try that again. Minus 8x squared. X squared minus 8x squared over x squared equals 7 over x times x squared. All right, so this becomes x squared minus 8 equals 7x, because you subtract exponents. This x cancels one of the x's in the x squared. To put this in standard form, we subtract 7x from both sides. And then we have x squared minus 7x minus 8 equals 0. If you notice, this actually matches with option letter C. So we have two matches right now, C and D. All right, let's take a look at E. We have x squared minus 3x minus 6 equals negative 10x plus 2. To put this in standard form, you just simply add 10x to both sides and subtract 2 from both sides. All right, if we do that, we have x squared plus 7x, x squared, let's use a black color. So x squared plus 7x plus minus 8 equals 0. Okay, and then option F matches with option E. It says x squared plus 7x minus 8. All right, so let's factor, since C and D are the same, how about we factor that first and see what happens? If we get, factor and solve to see if we get negative 1 and 8 as roots. So let's do C using x game. AC is negative 8, and B is negative 7. So what works here, in the factorization, we can use 1 and 8. Since the sum is negative, the bigger number has to be negative. So we can write this as x squared minus plus x minus 8x minus 8 equals 0. Okay? So we're going to factor that. Let me just draw a barrier here so we don't get confused. Do that again. Okay, so now break it down the center and factor by grouping. All right, so for the first pair, we have x times x plus 1 times x minus, this one is 2 times 2 times 2 times x minus 2 times 2 times 2. From the first pair, we can take out x, so we have x times x plus 1. And then here we can take out negative 8, which is 2 times 2 times 2, that's common on both sides of the right side of our partition. And you're left with x. Since you take out a minus, this becomes a plus 1. So the factored form is x plus 1 times x minus 8 equals 0. And then to solve it, you set both of them to 0. All right, and then the first one is x equals -1 if you subtract 1 from both sides. And then the second one is x equals 8 if you add 8 to both sides. So we can see that option C matches the answer. So C and D, since C and D have the same answers or the same equation in standard form, our solution, let's make sure that no other one matches. Let me check A and B to make sure. So A doesn't match, B doesn't match, so it's just C and D. So our answers are solutions. We have two answers here, option C and D. Okay? All right, let's take a look at the last one, question number 19. So we are to solve the equation. Solve 5x squared t plus 10xt minus 75t. So to do this, we're going to break everything down. So we have 5 times x times t plus 2 times 5 times x times t minus, if you break down 75, 75, you have 5 times 3 times t. So the question is, what's common in all three terms? We have 5, 5, 5 common. So we can factor that out. Take out 5. And then we can also take out x, and actually t. T, and t are common. So we see that 5t is a factor. All right, we're going to be left with x squared plus 2x minus 15. Okay, so let's factor the inner term in this parenthesis. So make our x. So AC goes on the top. AC is -15, and B is 2. So what two numbers work? We can use 5 and 3. Since the sum is positive and the product is negative, the smaller number have to be negative. Okay? So we have 5t times x squared plus 5t minus 3t minus 15. Break it down the center of factor by grouping. So we have 5t times x. My x is changed into t's. Let me change them back to x's. So 5x minus 3x. All right, so we have x times x plus 5 times x minus 3 times x minus 3 times 5. So from the first two, we can take out x. So we have 5t times x plus 5, and then minus 3, and we're left with x plus 5. So the factored form is 5t times x minus 3 times x plus 5. All right, so our factors are b. We're sure that b is a factor. And then, let's see, do we have x minus 5? X minus 3 is also a factor, so we select D. Now, if you look at 5x minus 15, if I distributed 5 to x minus 3, what will I get? If I distributed 5 to x minus 3, I'll get 5x minus 15. So A is a factor also. Okay? If you notice, A is not in a reduced form. If I reduce A, I'm going to get 5 times x minus 3. So A is a factor also. All right, so there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel if you haven't already done so. And please feel free to share and post the comments to let me know what you think. More clips come with FileMath.com. Thanks again for watching and have a wonderful day.